that is Newton's law of gravitation. First, gravitation. Under this, let us study the first law, that is Newton's law. Newton's law of gravitation. Newton's law of gravitation. This Newton's law of gravitation, what does it tell? It goes something like this, the law. Every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So basic forces in nature has already been studied in the introduction part to physics. So Newton's law of gravitation is there, electrostatic force is there, nuclear force is there, strong nuclear force and weak nuclear force. The four laws. So we will study this in detail. So what does it tell us? Say suppose for example I have two masses. Say suppose for example, say this is m1 and say another object I have whose mass is m2. Okay, whose mass is m2. The distance between their centers, the distance along the line joining their centers, let it be say r. So what is Newton's law of gravitation? It tells that every particle in nature will try to attract the particle. So this particle will exert some force on this, so as a result of which it will try to get attracted. Similarly, this particle also will exert some force on this, so this will also get attracted. So it tells that Newton's law of gravitation gave the magnitude, correct? Gave the magnitude for the force between the two masses. He told that the force of attraction between the 2 point bodies or two masses is directly proportional to the product of their masses. So the product of their masses is m1 into m2, and it is inversely proportional to the square of the distance between them. And this force, since force is a vector, it will have both magnitude and direction, and this force always acts along the line joining the two centers, correct? So if I combine these two, I'll get F is proportional to m1 into m2 divided by r square. Or if I remove the proportionality sign, I'll introduce a constant called as gravitational constant. F is equal to g into m1 into m2 divided by r square. So this is a force formula between 2 point masses, that is g into m1 m2 by r square, where g is a gravitational constant whose value is 6.67 into 10 power minus 11. So in the proper unit, correct? So Newton, correct? Meter square per kg square. So this will be Newton meter square kg power minus 2. In the proper SI unit, this will be the unit Newton meter square kg power minus 2. Now here similarly, correct, this force, correct, what is the direction of this force? This force, correct, the direction is it always acts along the line joining the two bodies, So this is the direction, correct? So, and it tells that the force is always attractive. Every particle, if they have some mass, by the virtue of their mass, the two particles will always attract. That is what Newton's law of gravitation tells, that every particle in nature, because of its mass, will attract other particle with a force that is directly proportional to the product of their masses, and it is inversely proportional to the square of the distance between them, and this force always acts along the line joining the two centers, correct? So what is the force on this particle? The force on this particle is basically due to this particle. So in which direction this will try to move? This will try to get attracted towards m2. So this will be in this direction. It will be along the line joining the two centers. So this is the force acting on particle 1 due to 2. Similarly, what will happen? This also will exert some force on this, as a result of which what will be the force acting on this body? This body also will try to get attracted, and the force will always be along the line joining the two centers. This is the force acting on body 2 due to 1. And what is the magnitude of F1 and F2? The magnitude of F12 is equal to the magnitude of F21. Both will experience the same force. It is not that half this will experience and half this will experience. No, both will experience the same force. It is G m1 m2 divided by r square. Both will experience the same force. In contrast to this, if I see the force between charges, correct? So gravitation and electrostatics is a chapter. Electrostatics will be studying in second year, the 12th standard topic. It is a chapter where almost all the derivations, whatever we do here or whatever we do